And with that, I'm excited to hand things over to Alex. Take it away.
Thank you. Just to give you a little bit of background of who I am a technical marketing engineer, part of Siemens, but I am the bridge between the people who develop the software and the ones that are supporting you. So I get to see how the software is being developed, the roadmap, and I help everybody adopt the software. I also sit as the chairman of the IDX standard. So a lot of the conversation we're going to talk about is how do we collaborate between the two tools from Xpedition X, and IDX is that format. And I sit at that committee. I'll pass it over to Gregory to introduce himself.
Thank you, Alex. Hello, everybody. I'm glad you're here today with us. I really enjoy doing these. Little bit of background on myself. I'm an electrical engineer specializing in RF circuitry. Spent about 35 years not just owning my own company, but designing military guidance and communication systems. That's led me down all kinds of rabbit holes. I've worked with some really interesting people and some interesting companies. After I got done running my own company, I've spent about 15 years, 15 and some change with Siemens, and I'm lucky to be sharing the screen today with my good friend Alex. He's going to show some really amazing stuff later. During my journey with Siemens, I got to do all things Xpedition, really focusing in on not just the ECAD-MCAD collaboration, but that came about as a result of the fact that I specialized in flex circuit, rigid and flex circuits. And now I'm with Saratech, so I have the ability to continue evangelizing all things EDA and the Siemens products to complete PCB boards, right alongside our friends that are doing the PLM stuff and the people that you probably already know and love. So we won't delay anymore. Let's just get right into what we're doing here. ECAD-MCAD collaboration is one of those things that solves a really interesting problem. Our industry faces a lot of challenges, and many of you are well aware of this. A lot of times our models don't sync up between the two disciplines, right? Now they're aligned and synchronized between the two tools. Everyone stays in their own domain, but we have this collaborator that sits between and helps kind of be the translator, if you will, or the helping hand to make sure we talk in our own disciplines, but crossing that border more effectively. The holistic interface checks. We have DRC checks on the electrical side, we have checks on the mechanical side, and now with the collaborator sitting between, those checks are kind of aligned and we have much better collision detection of what's going on and more close to real time than we had ever. And the ability to find areas where shorting may occur. Many of us have built boards and found that we put them together, put them in the system, and screwing down a screw, for example, like you see in the graphics here, we shorted some things out, right? Whether it be a signal or it's catastrophic like this event where it was actually a power ground short, right? We've all had those kind of problems, and this really helps alleviate that. And my personal favorite is this last one here, the synchronization. We all know what it's like to send an email and hope someone sees it today or tomorrow and replies back. Now, with the ECAD-MCAD collaboration, that synchronization happens much more rapidly and it's tracked. So NX and Xpedition, we like to talk about this digital twin. You may have heard the digital twin and the digital thread. We're going to talk specifically about the digital twin for a moment. That's the actual piece that represents our board, right? And NX and Xpedition, they've been integrated now and really improve on the IDF interface, right? A lot of us have sent data back and forth in IDF, and we know that it's very static, right? We get a bare minimum of information. We get some holes, maybe a board outline, maybe some keep outs, very minimal data, right? But now when we move into the world with a digital twin and the IDX interface, and you notice I got a real bad choice of words, right? IDF versus IDX, you got to enunciate, right? We have a lot more data, as you can see here, and that's just the tip of the iceberg as far as the Xpedition NX interface goes for this. We finally get to put a lot of things that we haven't historically been able to communicate through the IDX interface. And one of my personal favorites is the fact that we can now handle RF elements, right? We can handle the cavities. We can handle those RF components being mounted down in the cavity, right? Specific filters and things that we couldn't recognize as an RF element on the board before, and of course, wire bonding. And then the one that's near and dear to my heart is the flex information, right? There's a lot of crazy stuff that historically mechanical and electrical just didn't understand. We had to fake a lot of things. We've come a long way in just a few years, and Alex has really pushed hard to make sure we get a lot of this. We get the multiple board areas, we get the information of the actual stack up, we get the real thicknesses, right? And one thing that's super important here is we're able to bend not just the flex substrate and treat it like a solid, but we can bend the actual copper, right? And that really makes this rigid flex piece shine. So I talked about this is where the digital thread really shines. It's in this EDMD or ECAD-MCAD collaboration exchange. This is where things really shine. One of the things that are important to know is that when we have this digital thread, that's the metadata, the data that we send up to Teamcenter or your PLM, right? And specifically, I'm going to talk to NX, Teamcenter, and Xpedition, mainly for obvious reasons, right? It's the tightest integration that I promote, but there are others, but I'm going to stick to those three for now. The digital twin, like I was talking about, that's really the 3D representation of the board, the physical board. And you can see that by being able to have these communications, we reduce respins, right? And we pulled out some very important areas that respins happen. Not representing the 3D board properly, so mechanical and electrical can check it out. That causes respins. 3D interface checking. Do we have any collisions? Do we have anything hitting the chassis? Do we have a connector backwards, right? That can cause respins. And the last one is this model exchange, right? If we don't have the models correct between the mechanical world and the electrical world, we run into all kinds of problems. So the difference between IDF and IDX is really what we're talking about here with synchronization and design intent. It's real hard to show what your design intent if you're not able to visualize what it is. If you're like me and you're a visual learner, this 3D realm really adds a lot of life to what we're doing. And being able to propose and reject. If I send something over to my mechanical team from the electrical side, they have the ability to review it and say, no, you're crazy. You can't move that connector. It's going through a front panel, for example. So having ownership and the ability to control that's huge. And we're also moving from one giant data dump. When we did the IDF, you just dump data over the fence, give it to mechanical, and pray that they can implement it or they understand your intent. Moving away from that to a live data process where we forward data back and forth and stay in sync is huge. That's a better workflow, and you know what's changing when, and if that change was wanted. It also gives you who made the change, right? For me, these are huge. The board geometry, this is where we've grown by leaps and bounds here. Xpedition and NX are able to better understand the entire board information, not just the pieces, but everything, the materials, the layers, the various board regions, available thicknesses. There's no other solution out there that's as holistic, and no other vendor has this level of communication. Our component exchange, this is the 3D model exchange. One thing that's unique to NX and Xpedition is we know the IPC standards for these components, and the mechanical team at Siemens has been able to put this intelligence into NX so that it recognizes what we've got here. And that's tied directly into this 3D model exchange and the MCAD model, so that we can work and make sure everything's not just aligned, but those parts are recognized to be the same part, origins are the same, thicknesses are the same, landing patterns are the same. Makes a big difference.
That's a big point that Gregory is saying, because there is no other vendor out there that has ownership of both ECAD and MCAD. And with that ownership, you can see we have an aligned roadmap to work and collaborate on in this case, component information. So there's a lot of information we can get that. And now that you have the best-in-class experts that are designing ECAD software and the best-in-class defining MCAD software, we're building a lot of ECAD software into the mechanical system. We're building a lot of mechanical system over to the ECAD system, and you'll see that in the demo later today.
Thanks, Alex. The copper transfer, this is something that's kind of a double-edged sword, right? Mechanical always tells me, stop sending me so much information because it makes a giant database, right? Well, that is true. And so what I like about being able to do this copper transfer, the way that they've done it now with the synchronization, I don't have to send it over every time. I can wait. I can make sure I have the board done. I've got my copper ports for my planes done. I've got special features for syncing. The conductive shapes are all in there. My traces are in there. Solder mask is in there. But I don't have to send this over all at once. And more importantly, I don't have to send it over in a static format. I can send this over in what's called an external file. And what I mean by that is it's a file that NX is specifically waiting for and looking for, and it understands things like traces, the pads for the components, all my planes and fiducials, wire bonds, solder masks, things that I kind of glossed over earlier, and even reuse circuits, right, that are being used in Xpedition to step and repeat a circuit that you're going to use multiple times, right? All of this goes into an external file, and that data is live sent over to NX, and it's understood. It's not just feeding features over and hoping for the best anymore. And this really helps with us being able to do that clearance checking I was talking about and setting up rules both within NX and Xpedition so that we're syncing together on all the data live.
And you can set up those rules all the way up to the net name. So it has that granularity.
Excellent point. And the reason that's huge is now the electrical and mechanical can just say it's not that net right there. We can actually use the name. And on the Xpedition side, visualize it. I don't think we're quite that far on NX.
The key advantage here is that a lot of the times that you bring in copper information is for interference checks, and people are doing like hot and cold vias. It's like a very common use case. You have a ground or power attached to a via versus just a normal net. And when you have a power signal attached to a via, you want the spacing to be further away from your assembly object that may sit on the surface of the substrate. So we convey all this information. This is what we've been doing more and more ever since we were acquired, is that we pushed the ECAD data, the net name, the geometry, and the information necessary so they can actually see this information and do it DRC, saying, hey, my 5-volt rail has to be 2 millimeters away from my assembly object in the X, Y, or Z.
I mentioned earlier that Flex and RF were kind of near and dear to my heart, right? And so hopefully they are to you. I noticed it solves a lot of problems in the industry right now, but having this advanced data exchange specific to rigid flex and the substrates, the bend areas, and the stack ups, I can't tell you enough how huge this is, and NX is the only mechanical package that understands these nuances, right? And the stack up schemes, being able to have a different stack up. I may have a rigid board out in the middle of an end where you see this connector bent up. I may have a rigid board or just a stiffener out there. And just knowing what those materials are and the ability to know that it's a net going through those legs, this is huge. Being able to have one board thickness out at that connector, another at the inner board where multiple connectors tie in, or the main motherboard, if you will. I can even have a metal extrusion mounted to this with my RF circuitry inside of it, like you see at the top of the screen here. These are all things that we had to kind of finagle and fake, if you will, in the past. And now it's integrated, it's known from end to end, and it truly is a digital twin that's correct by construction.
Going back also to the copper instances, that we also bend the copper. So a lot of simulation tools that you look at today, they take ODB++ or Gerber or some other format, and that's a flattened shape. 2D PCB design is typically done in a 2D design. So mechanical needs to see it, that copper flexed in the 3D domain in order to do proper vibration testing, stress testing, and thermal. So if you look at all the other competitors and the other solutions out there, they're really working off a 2D package, whereas we convey that all the information necessary to create that 3D element that is the actual representation of what you're going to release out into the market for your product.
Thanks, Alex. And I think it's important to let everyone know that we're really doing a great job here building the ECAD domain expertise and information into the MCAD tool realm, right? And it's being built in a way that it's being built for the mechanical designer. We don't want everyone to have to understand a new way of doing things. We want you to work in the tool that you have, be comfortable with the way you're doing things, just have more information available. Would you agree, Alex?
Yes. That's our goal, is that we implement functionality over to the other domain, but we don't want to change how those designers operate. We want mechanical designers in NX to have the look and feel of how they're doing designs in NX today. We want Xpedition designers to have the same look and feel. So they're not translating and trying to do mechanical work inside of an ECAD tool and vice versa.
Well said.
Having access to that information.
Okay, so the electrical mechanical exchange, what does that workflow look like, right? So I'd like to show you guys just graphically real quick what a typical data workflow would look like in this process, right? So you can see here we've got an NX assembly. It's pretty bare. We've got a board outline. We've got some connectors on there. It would be pretty unique if it didn't start this way, right? Mechanical typically tells me what my constraints look like. I've got a panel that they have in assembly that my board's going to have to mount to in some way. I got some connectors passing through. All this should look pretty normal if you're a mechanical folk, right? Once they get this to a certain point and they think, okay, well, we've got this nailed down, we can send it over and let the electrical guys work. We send over what's called a baseline file, and that IDX there, that's the IDX format that carries this intelligence forward to the Xpedition side. And this establishes the initial intent coming into Xpedition. Then the Xpedition folks, the electrical engineers, do what they do. They place components, they route some critical nets and things. They do the typical electrical stuff, you know. When they get that to a certain place, it's time to sync up with the mechanical folks. And I love this particular part because everything that's done on the electrical side, we send that proposal back to the NX team, the mechanical team, and that has everything I've added, modified, deleted, moved by accident, and they can look at it and see, and this is really important, they can look at it and see, did I move a connector that was important? Did I bugger something up? A technical term, bugger, right? And they'll send a response back with either accept or reject. If they reject, it's on me to see that they said, no, that cannot be moved, you can't do it. Or if I moved a component or something to get it away from a connector, they probably accepted that and said, hey, this looks good, everything's locked down and good, move on. And I really like that because this is where you have a say, right? Mechanical doesn't have to just be like, well, the electrical guy moved a connector, now it's my job to make sure I get it back where it was. The important thing to say here is with that rejection, that component will go back to the coordinates it was on before it was moved initially. And that's something that's been missing, right? We've always tried to realign things, and it's really annoyed my mechanical friends when I nudged a connector and then they're trying to put it back in the exact location it was, right? Or worse, rolling back a revision level to get it back and everything, right? So then the response comes back into Xpedition. We finish laying copper pores, solder masks, things like that. When it's complete, on the electrical side, we send what's called the externals. The externals we talked about earlier were those copper pores, solder masks, right? Things like that that don't fit in the normal proposal. And that would be for the final check in mechanical so they can do as they need and take care of this from there. Alex, is there anything you want to add here?
So the key overall goal here, obviously we recommend that you start with MCAD because typically MCAD owns the board outline. And they own where connectors should be placed or specific components that are interfere with the mechanical assembly. But it's all bi-directional. We know all designs don't fit the same glove. You need different mechanisms to transfer. And you could start your baseline from Xpedition if necessary. You could start from NX. But in most cases, they should go along from the NX state. And the key thing here is that what Gregory is saying is the incremental. The incremental is very different to what you're doing in IDF. IDF, you're throwing over a wall and then hoping that like they've actually accepted or like brought the changes you did to the other domain. Proposal means that only the things that have been added, deleted, or modified are getting sent. So instead of getting 10,000, 50,000 changes, you're getting a couple dozen. And then you can preview and verify the changes. And that's what the response file, which Gregory was describing, which is making sure that the two domains are in sync. If somebody rejects something and doesn't move the component, it resets that component to its original location in the other domain. So you're both working off the same database. So the one thing I want to highlight is that this is a preview, a short demo of the overall workflow to get you familiar with the functionality. We have a lot of features that we have developed over years of development time on this. So if you're interested to do a more deep dive, you can reach out to Gregory, myself, and we can go into a lot more functionality. But the main goal, what I'm going to show you is just how do you collaborate? How do you send that initial data set and propose back and forth? But if you want to poke into that flex transfer, PCB variants, component exchange, library synchronization with Team Center, we can always schedule something afterwards because there is a lot of functionality we have built. So in this example, you can see sort of similar to Gregory's slides. We have a board outline. This is defined by MCAD. We have some mounting holes defined with a panel that's brought in with some connectors that have been placed into the assembly. These have all the attributes added. This can be fed into a bill of materials that through our Xpedition to Team Center integration, as well as other mechanisms. But the mechanical designer will have access to all the attribute information, so they don't have to guess what part is being used in that particular design. The other thing is that we have a mix of electrical and mechanical components. We have a heat sink and we have a panel. Some these elements won't exist in the ECAD database. But we want to reuse them, and we don't want to rebuild them I've seen many people take DXF files, placement keepouts, and redraw them in the ECAD domain. But really, we should just reuse the work that the mechanical designer has done and just take advantage of it and bring it automatically into Xpedition, and that's what we do. So in this case, I haven't started my collaboration, so I want to create my baseline. And if we go to create our baseline, I'm going to clone the assembly. And when I clone the assembly, it's going to take all my alignment, all my mechanical parts that I've assigned into my design, and it's going to bring it out to an assembly file that I can bring into Xpedition. The baseline file also contains all the information for the board geometry, as well as the component locations and other information like placement keepouts and holes in the design. So one of the key things we want to highlight is that everything can be accepted or rejected. So you can see we have a checkbox next to every object, so we can preview the information before we import it. So in this case, I can see my board outline. We can see the thickness is 882 microns. MCAD usually owns the thickness, ECAD owns the stack up. And that's one of the things that Gregory was saying in the PowerPoint is that we actually send that stack of information over to MCAD so they can place copper in the right location. They can create a stack up PMI table for drawing. They can even create have a solder mask reference set for interference checking because they place the components on the right location. But in this case, this is a baseline. We understand that we want to create that initial data set and we want to apply everything in the design. And so what it's doing and what's different than IDF is that it's looking at every single one of those objects and it's providing a UID associated to each object. So it takes that IDX file and puts it into the history section. So we can see a couple months later what was accepted or rejected. And then every subsequent collaboration, we only see what's been added, deleted, or modified. So you can see we have our Xpedition design. We have our components. There's also like, I'm skimming over a couple features like object ownership, where you could actually prevent ECAD from even moving those connectors. So if you set the ownership in NX, like Gregory was saying, and so it prevents the ECAD guy from moving anything. I can import that assembly file that was automatically created when I created that baseline. And I get those mechanical components and I can do interference checks associated to it in the design. So it could be a single component, or in this case, it's around a couple dozen because there's several elements associated to the panel on the front end. So you're getting more and more information from the mechanical domain into ECAD to make your proper component placement and strategies so that you avoid violations. So you're not cleaning up at the end, you're creating a better design while you're creating your PCB. So I'm going to use a placement file. I don't want to fake it and just place like a couple components. I want to have at least a couple dozen. So we're showing like how we can send a real design over from the other domain. We have a 3D model exchange too. So one of the things that we can highlight is that we have a starter library as well as many sources to get the 3D models into the design. I can search for a part, I can apply it, and automatically assign the 3D model, which you see there. We can convey that information over to MCAD. And one of the advantages of building on the ECAD side is that you see the component paths while you're assigning the 3D model. So you can see where pin 1 should be, which we also send in the IDX file. And we can make sure that the two components are aligned between each other so you don't have those respins that are caused by a mismatch. So in this case, I have my proposal. I've added around 91 components, and you can see some of these actually have a B next to it, and it shows that they have variant configuration. So this is another thing where we're transferring over ECAD information. Variants are defined by the ECAD designer of components being unplaced or replaced, and we want to send it over to mechanical. So in this case, we want to send all these 91 components in the proposal, and we're going to send it over to MCAD so they can consume it, get the component placement, build the 3D models if they don't have it in the Team Center library using the 3D geometry that I just assigned. And we can also add the additional attributes like the pin 1 location as well as the variant configuration. So if I browse to that proposal file, and you can see the information. I can preview, but out of the sake of time, we can see all the components. You can see that I haven't sent anything on the board. I haven't sent any keep out restrictions. I haven't sent any mounting holes. It's just the 91 components in the design. I can, for any of these elements that don't match my design requirements, I can just reject. I can reject all the changes. But just for now, for this use case, we're going to accept all changes, and it's automatically going to capture my whatever I've chosen in this dialog, and it'll send it in a response back to the ECAD designer so he knows what elements I've accepted, what elements I've rejected, so they can reset on the other domain and keep us in sync between the two. Once this is brought in, you can see the components. You can even see it created the variant configurations on here too. So we're now synced. We have all our components. We have our these 3D models were built on the fly. We have different configurations that we can have. The very quick tidbit is that you can see the variant configurations with the unplace and replace. I have 2 variants in my design. The full has everything configured, but if you do the DNP, the do not place variant configuration, you can see a couple of components were unplaced, and we can show it replacing. There's a lot of things we've done to make it better because anything that's unplaced is suppressed, so you can do interference checks and it won't give you a false violation. You can do thermal checks and it's not included in that thermal check if it's not part of that variant. And the last thing to finalize and bring into the Xpedition design is to close the loop. So I need, the mechanical designer basically went in and accepted all the changes. So you can see everything is checked in my design. We need to make sure that he hasn't rejected anything, or we need to reset and synchronize with the other domain. And throughout the whole process, if you look at MCAD Collaborator, we try to guide you on what you need to do. So you can see we have sent a proposal and we're waiting for the response that's coming back. And we try to provide a little tree to allow you to understand what proposal and response they belong to. We have naming conventions. We have a code design within Teamcenter to help manage this whole process back and forth. In this case, I just want to apply the response, and you can see that everything was successful. We're synchronized, and we can send information back and forth. So we have data completed our first exchange. This shows that instead of doing your typical processes where you're collaborating at the end of the design cycle, you can collaborate at the beginning all the way to the end, making a more robust design, better collaboration between your 2 partners, and you'll be able to create designs quicker and with less errors. So I think that's probably the amount of time that I have for this demo. But if you want me to go in more detail, if you need more information, you can reach out and contact me, and we can go into a large, robust feature set that we have implemented today with Xpedition and NX.
Yeah, one of the questions that we have, it just connected to the difference between digital thread and digital twin in this context. How does IDX enable both of those?
So the digital twin is handled in IDX representing just the PCB and its components and the things on the electrical side. The digital thread would be all of the design metadata, the rules checking, any code files you had for FPGAs, things like this. All that extra data would go to Teamcenter. And so that would be the digital thread piece.
The key thing that people like about the digital thread is, well, the main thing that they want is the BOM. The BOM and Teamcenter, what we've also built onto it is library synchronization. So the BOM, we provide all the information available within the item in Teamcenter. So we give the part name, the manufacturing properties, and we also give the part number and cell name. And so we've actually, this is one of the advantages of being part of the same umbrella, is that we noticed that NX and other mechanical tools didn't really understand what an alternate cell is, and that it's different representations for the same part you would buy off a shelf, but you would insert it differently on the board. And so through this digital thread, we built a library synchronization where you could get 3D models with the alternate cell representation and build it into NX. And then you would have a choice in NX to choose between those representations, and you would know that it's the same part number, but it's just a different choice. And the mechanical guy can decide what should be the representation, or the ECAD guy. That they have all the information available.
Awesome. Thank you guys so much. These sessions are short and we only get to so much. So if you are interested in any more learning or hands-on help, we have some courses on our website. Please reach out to us if you're interested in any of these. And if you have any additional questions, comments, you can email us at marketing@saratech.com and we can get you connected. So we appreciate you being here. Thank you both so much and have a great day, everybody.